Hello to all, welcome to the channel Mani's GATE Tech Vision. In this video, I will solve the GATE 2024 problems for the subject Signals and Systems from the discipline of Electrical Engineering. The topic which I have taken is common for electrical, electronics and instrumentation. So all the branch candidates can watch this video completely and clearly. Let me start solving the problems one by one. This is problem number 1. I have taken this problem from EE paper, GATE 2024 electrical paper. Okay, first I will read out the problem. Suppose signal y of t is obtained by the time reversal signal x of t. So here y of t is given as the time reversal signal which is represented as x of minus t. Which one of the following options is always true for the convolution of x of t and y of t? Observe clearly which one of the following options. So it is a MCQ type of question. Only one option will be the correct one among these four options. So here signal y of t is given as time reversal signal. We need to find the nature of convolution of x of t and y of t. Okay. So let me write the signal. Let me start solving the problem. So here y of t is given as time reversal signal x of minus t. We need to find the nature of the convoluted signal of x of t and y of t. So let me write convolution of x of t and y of t. So convolution of x of t and y of t. So I am going to represent the convoluted signal as W of t, which is the convolution of x of t and y of t. Now y of t is already given as x of minus t. I am going to replace y of t as x of minus t. So a convolution of x of t and x of minus t. Let me take this as first equation. So for checking whether the signal is odd or even, we can replace the time by t by minus t. So representation will become W of minus t, which is x of minus t, convolution of x of minus t and y of minus t. We can keep x of minus t as such. So already y of t is given as x of minus t. So y of minus t means x of minus t, which can be represented as x of t. This is taken as second equation. Now compare first equation and second equation. This is the convolution of first equation is the convolution of x of t and x of minus t, and second equation is the convolution of x of minus t and x of t. So for the convolution, commutative property is satisfied, so that we can conclude the convoluted signal as W of t equal to W of minus t. Therefore, the convoluted signal is an even signal. Okay. So no need to check for whether it is a causal or non-causal signal. It is a MCQ type of question. So we can conclude this is an even signal. So option A is the correct one for this problem. Okay. Let me move to the next problem. This is problem number 2, taken from the classification of systems. Okay, let me read out the problem. Here, input x of t and the output y of t of a system are related as. One function is given. We need to find whether the given system representation is non-linear or linear and time invariant, or linear but not time invariant, or non-causal. Okay, we need to, this is the topic. The topic is classification of systems. Okay, let me check out whether it is a linear system or time invariant system or non-causal system. So let me start solving the problem. Let me write the function first. So here function is given as y of t equal to e power minus t integral minus infinity to t e power tau x of tau d tau. Okay. So first let me check for linearity, whether the system is linear or not. We will check. Okay. We will check for linearity. So for the system to be linear, superposition principle has to be satisfied. The system has to satisfy the superposition principle. So what is the superposition principle? So I will explain that. See here, listen clearly. Output due to weighted sum of input signals. Output due to weighted sum of input signals should be equal to weighted sum of output signals. Weighted sum of output signals. So here x1 of t and x2 of t are the input signals, y1 of t and y2 of t are the output signals, a1 and a2 are the weighing factors. This one is output due to weighted sum of input signals. Weighted sum of input signals. Okay, for the summation, for the sum, I have represented the summation, which should be equal to y1 of t and y2 of t are the output signals. A1 and A2 are the weighing factors. Weighted sum of output signals. Weighted sum of output signals. So we have to find out whether the superposition principle is satisfied for the given system. Okay, let me find the output due to weighted sum of input signals for the given function. Okay, so let me start solving the problem. See here, output due to weighted sum of input signals. That means the given input signal should be replaced by the whole term. Should be replaced by this whole term. Okay. So here in the given function, which is the input signal? Y of t is the output signal. X of tau is the input signal. I am going to replace this total weighted sum of input signals by x of tau. So x of tau should be replaced by the total weighted sum of input signals. So therefore the function will become e power minus t integral minus infinity to t e power tau. So in the place of x of tau, I am going to replace that as weighted sum of input signals. So a1 x1 of tau plus a2 x2 of tau d tau. Here a1 and a2 are constants, so we can take it outside, and then by taking a1 and a2 outside and by expanding this, a1 e power minus t integral minus infinity to t e power tau x1 of tau d tau plus again a2 e power minus t integral minus infinity to t e power tau x2 of tau d tau. So let me take this as first equation. Okay, and then we will find out weighted sum of output signals. Weighted in the right hand side, weighted sum of output signals. Okay, so weighted sum of output signal is represented as a1 y1 of t plus a2 y2 of t. So which is a1 into that whole function plus a2 into, so a1 into e power minus t integral minus infinity to t e power tau x1 of tau d tau plus a2 into that whole function e power minus t integral minus infinity to t e power tau x2 of tau d tau. Now compare this first equation and second equation, that is equal. So we can say the superposition principle is satisfied for the given system. So the system is linear. The given system is linear. So for the linear, we are having two options. We are having two options, linear and time invariant, and linear but not time invariant. So we need to check for the time invariance property also. Okay, so let me check for the time invariance also. System is linear. So now we need to check for the time invariance. Same problem only. In this page, we will check for the time invariance property. Whether the system is time invariant or not, we need to check. Okay. So let me write the condition for time invariance. So how we can check whether the system is time invariant or not? Let me write the condition. What is the condition for that? Y of t comma t naught equal to y of t minus t naught, which is y of t comma t naught is output due to delayed input. Output due to delayed input. Okay. Y of t minus t naught is the delayed output. Output itself delayed. Delayed output. Okay. So let me find the system, find whether the system is time invariant or not. So let me take the left hand side, output due to delayed input. That means input must be delayed by t naught seconds in that function. So here function is same function only. So y of t comma t naught. So what is the input function here? Input function here, input function is x of tau only, the input function. So that x of tau should be replaced, the x of tau should be delayed by t naught seconds. That is a condition. So let me write the function for that. So y of t comma t naught will be equal to e power minus t integral minus infinity to t e power tau x of, in the place of x of tau, that input function should be delayed by t naught. Input function should be delayed by, take this as first equation, and then delayed output. Now we need to find the delayed output. So y of t minus t naught. T minus t naught. For this we can replace the time. We can replace the time by t minus t naught. So if in the place of e power minus t, we can replace that t as t minus t naught, and then integral minus infinity to t minus t naught. Then e power tau x of tau d tau. Okay. In the place of time, we are going to I am replacing that t by t minus t naught. That is a delayed output. So let me take this as second equation. Now comparing this first equation and second equation, this is not equal. So system is said to be time variant system. That is not time invariant system. Okay, one is not equal to 2. Time invariance property is not satisfied. So we can conclude that system is not time invariant. System is not time invariant. So already we concluded that is linear. So among the for B and C option, linear but not time invariant. So option C is correct one for this problem. Okay. So let me move to the next problem. Problem number 3, which is taken from the topic classification of signals. This is one of NAT type question. NAT type question means numerical answer type question. There will be no options. Fill in the blanks type question. So first I will read out the problem. If the energy of a continuous time signal x of t is E and the energy of the signal 2x into 2t minus 1 is CE, then C is. Okay, we need to find the constant C. Energy of x of t is given as E. Energy of another function is given as CE. We need to find the constant C. Okay, so let me start solving the problem. Let me write the function first. See here, energy of x of t is given as E. And then energy of 2x into 2t minus 1 is CE. Okay. So let me write the energy equation first. What is the energy formula? Energy formula is integral minus infinity to infinity modulus of x of t whole square dt. So this is the energy formula. Okay. So let me write for this also integral of minus infinity to infinity. So in the place of x of t, I am going to replace that as 2x into 2t minus 1 the whole square into dt. Okay. So now this 2 is constant. 2 square is 4. So we can take 4 outside. So 4 into integral of minus infinity to infinity modulus of x of 2t minus 1 the whole square dt. So for the simplification purpose, let me take this 2t minus 1 as another variable. Okay. 2t minus 1, I am going to change another variable. 2t minus 1 is y. So then differentiating on both sides, 2 into dt equal to dy. Okay, therefore dt equal to dy by 2. Okay, let me change the limits also. If t equal to infinity means 2t minus 1 equal to y means y equal to also infinity only. T equal to minus infinity means y equal to minus infinity. There is no change in the limits. So we can write CE equal to, from here, CE equal to 4 into, I am changing the limits for y variable. So integral minus infinity to infinity, in the place of x of t 2t minus 1, we are going to write x of y. Modulus of x of y whole square into, in the place of dt, I am going to replace that as y variable. So dt equal to dy by 2. Dy by 2. So therefore 1 by 2 we can take it outside. So 4 by 2 integral minus infinity to infinity modulus of x of y whole square into dy. Okay. So this will get cancelled. This is 2 into integral of minus infinity to infinity modulus of x of y whole square into dy. See, observe this equation. This equation is nothing but an energy equation. So 2 into E. Okay. So therefore CE equal to 2E. Therefore the constant C equal to 2. The answer is 2. Answer is 2. So for this problem, answer is 2. Okay. Let me move to the next problem. Problem number 4. This is taken from the Laplace transform. I'll read out the problem. If u of t is the unit step function, then the region of convergence of the Laplace transform of a signal. So signal representation is given. We need to find the region of convergence. Okay, this is an MCQ type of question. So first we need to find the nature of the signal. So let me write the signal first, and let me find the nature of that signal. Okay, so here x of t is given as e power t square into u of t minus 1 minus u of t minus 10. So let me represent for u of t minus 1 and u of t minus 10 first. Okay, we are going to check whether the given signal is finite or infinite first. So we know u of t minus 1 is nothing but unit step function is delayed by 1 second. Okay. So it will be starting from 1. So this is the signal representation for u of t minus 1. And for u of t minus 10, for u of t minus 10, it should start from 10 second. Okay. Signal is delayed by 10 seconds. So u of t, now this is a subtraction of u of t minus 1 minus u of t minus 10. So that signal representation will be finite only. That will be from 1 to 10 only. So u of t minus 1 minus u of t minus 10 representation is the step signal will start from 1 second to 10 second. Okay, 1, 10. So this is the signal representation for u of t minus 1 minus u of t minus 10. So now observing this signal is finite from starting from 1 to 10. It ends at 10. Okay, it ends at 10. This finite signal into that exponential signal will be the exponential finite signal. So we can conclude that this given signal is a finite signal. Given signal is a finite signal. Finite signal. Okay, given signal is a finite signal. For a finite signal, ROC includes entire S-plane. Entire S-plane. Okay. So we can write the ROC as minus infinity to infinity. Minus infinity to infinity. So ROC is minus infinity to infinity since it is a finite signal. So option A will be the correct one for this problem. So thus we have solved 4 problems from the electrical. This is Mani's Gate Tech Vision. This is a channel for engineering lectures. This lecture is useful for engineering competitive examinations. You can view the lecture series. You can subscribe to my channel. Thank you very much for watching the video. If any queries means you can mail to me. My mail ID is dmoneylecture@gmail.com. Thank you very much.